Hi everyone. So let's now start our next topic, which is subnetting, right? This is easy topic, very short topic, very easy topic. Let's just see what is subnetting. So subnetting is a process of dividing a large network into smaller, more manageable subnetworks. So what does this mean? You will get to understand. Okay. So basically what we do, if there's a large network, we will divide this into subnetworks, right? How do we divide it? We will get to see, okay? So the process is called subnetting. That's what we need to understand in this slide. So the definition goes like this: that we divide the large network into smaller logical subnetworks by borrowing bits from the host ID part. So how do we do it? We borrow some bits from the host ID part. Okay, with the example, obviously you will get to understand more. So for now, see this physical structure. Suppose there is a router which is connected to these three departments like this. Now, suppose I want to have a different subnet for each of this router or each of this department. Then what do? I place a router, okay, for each of the department, and then we call that, okay, this is one subnetwork, this is another subnetwork, this is another subnetwork. Okay, I mean, you don't need to call it subnetwork, you can directly call it network. So this is another network, another network, another network. These three networks are basically forming basically, I mean, separately they are subnetworks and they are forming a complete network, right? So earlier this was a single network, now we have divided into subnetworks like this, right, by placing the router. Okay, so why we do it? Because suppose there is some facilities that I want to give to electrical department and not want to pass to computer science department. Suppose there are some electrical related resources or electrical related websites that I want this department to access. Then I will do one thing. I will not let the CS department to access those things, or maybe it is for the management purpose also. For example, like if we divide in the subnetworks, then it is better. Like if I want to broadcast something only to electrical department, or electrical department want to communicate within themselves, then it is good, right? I mean, you don't have a single network where if you broadcast, then everyone will see your message. It's not like that, right? If only electrical department, within electrical department you want to communicate, you can definitely communicate. And similarly for the art department, similarly for the computer science department, right? So you can do like this. So that's why the subnetworking is useful. And other than that, there is no single point failure. I mean, earlier if this router is failed, then obviously like everything is failed, or not just fail. Like, I mean, if you want to manage, then every load is on this router. Now you have divided the load to the different routers like this, right? So that's why the subnetworking is useful for many of the purposes. So how we do it? Suppose there is some IP address, okay, or there is some network 198.3. Let's suppose 5.100. Okay, I mean, this is the IP address, but let's suppose the network is /16, which means this is fixed and everything else is you can change. I mean, these you can change to 00 if you want to write the network ID. Okay, you can change to 00. That's fine. So this is 0, this is 0. Okay, so this is the network ID for the network, which is /16. Now, if I want to divide this network, let's suppose into some parts, okay, let's suppose into 4 parts, then I will borrow some bits from the host ID, which means that currently the host ID is 16, like 16 bits are host ID. I will take some bits from here. So basically, let's suppose I'm taking 2 bits, okay, 2 bits of the host ID I'm taking, and then 2 bits I'm assigning as a subnet. So I will borrow some bits from the host ID, and then I will call it this is subnet ID. I mean, completely this is a network ID, or complete this is a subnet ID. But these 2 bits I need to borrow if I want 4 subnets. So how do we do it? Let's just see with the example. Okay. So suppose a company has 4 departments and each department has few hosts. Then we can separate basically the departments, right? Okay. Let's just see that how we do subnet. Let's just see the real working of the subnet. That how we really do the subnetting. So what we do, given a network, we divide this into 4 parts. Suppose 1, 2, 3, 4. We divide this into 4 parts, 4 equal parts, right? Now, since this is /24, which means that 24 bits are already fixed, right? 24 bits are already fixed. Then what you need to do? You can just change the last 8 bits. I mean, from the last 8 bits, basically you need to borrow some bits, right? So which means 192.168.9 till now this is fixed. Now I'm writing in the binary. Okay, I'm writing these 8 bits in the binary. Okay, so these are the host bits actually. I mean, I do not need to write 0. You can write XXX also, but yeah, because these are changeable bits, these are the host bits. Now since I want the 4 subnets, so I will be borrowing two bits from here. Okay, so I will say that, okay, let me borrow 2 bits from here. So basically, let me write in this way, that these are the 8 bits, right? So host ID has 8 bits, 1 2 3 4 5 6 7 8. Okay, now all of these 8 bits could be anything. Let me write x, I mean depending on the host number. Now what I do, I borrow these 2 bits, and using these 2 bits I say that okay, this is subnet 1, subnet 0, or like that, right? So which means I say if these 2 bits are 0 0, these 2 bits can be 0 1, these 2 bits can be 1 0, and these 2 bits can be 1 1. I mean these 2 bits can change with the 4 possible combinations, right? So which means if I keep them 0 0, then the whole network will be 192.168.9.00, and then these 6 bits could be anything, 1 2 3 4 5 6. Okay, these 6 bits could be anything. Getting my point? I mean this 0 0 is fixed. So slash earlier it was 24, now the 26 bits are fixed, so I will say slash 26. I mean each of this network is slash 26, obviously, right? Each of this network is slash 26. Okay, each of this network is slash 26. Now if it is 0 1, then what will be the network ID or what will be the subnet ID for this? Then in that case you will say, if it is 0 1, then in that case you will say, so see, with the lack of space I'm trying, little hard to manage it, but yeah, that's fine, I think. Okay, I'm writing this here. The network here will look like this. Okay, if it is 0 1, then it will be 0 1 like this. Okay, which means the network ID here will be 64. I mean here the network ID will be 192.168.9.0/26. Here the network ID will be 192.168.9.64/26, right? Similarly it will be 10 here, right? So 10 means 192.168.9.10, and then these 6 bits could be anything, /26, right? So which means the network ID will be 192.168.9. Since it is 1, then 128/26. I mean every network is /26 anyway. Okay, and then what will be this? This will be again, you can write 192.168.9.11, and then these 6 bits could be anything, /26, which means the network ID will be 192.168.9. This is 128 plus 64, right? 128 plus 64, how much it will be? 192, right? 192/26. So these are the network ID. I mean /26 you don't need to write for the network ID, obviously, but yes, this is the network ID. Okay, let me write network ID. So subnet, you can also say subnet ID. Okay, I mean doesn't matter. So subnetwork and network both are the same thing. So network ID, this is also the second network ID, right? This is also the network ID. Sorry, I mean this one. Okay, this one is network ID. Here this one is network ID. Here this one is network ID. So these are the network IDs. I hope you understood that how we are dividing the network into 4 parts, right? So what is the first step? Very easy. The first step is basically, let me just show you. The first step is to basically just have 4 parts. I mean just draw the 4 lines. That's the first step you can consider. Actually it is very easy. It might look little scary, but to be honest it is very easy concept. So you need to have 4. Okay, since you need to have 4, that's why you need 2 bits, right? If you need to have 8, either you can have 4, you can have 8, like this. Okay, so we will see questions, don't worry. But yeah, if you have 4, then you need 2 bits. Then if the 2 bits could be 0 0 0 1 1 0 1 1, like that, right? Obviously these are already fixed because of /24. Now it will be /26 because 2 bits are further fixed, right? Then what you do, you basically say that now you have, okay, now you have written, let me remove other things. So now you can write the network. Don't worry, I have already copied all the things on the page. Okay, on the next page I have already copied all the things, so I'm just removing these things. Okay, so yeah, so then you can say, okay, then this is 0 0/26, this is 0 1/26, this is this is 1 0/26, this is 1 1/26. That's all you need to just claim. Okay, that's all, and you're done, right? And you're done. Yeah, subnetting is actually done. Like there is nothing more in subnetting. That's all. Okay, and then you can find out the network ID and all, right? So let's just go to the next page, and let's just have this very cleanly. Okay, so let's just have it this very cleanly. So let me just go to the next page probably. Yeah, so these are the 0010101011. These are the subnets and these are the ranges. Okay, so let me just show you in a very clean way. So what we are going to do, we are going to have 4 subnets, 1, 2, 3 and 4. We are going to have 4 subnets, 192.168.9.0 slash. Okay, so here you can have 00. Let me write it 00. Okay, and then yeah, these could be anything in slash 26, right? Similarly, sorry, so yeah, you can have 01, 10 and 11. Okay, so these are the 4 networks we have. So here you will be 01, 10 and it will be 11. So let me quickly write it 01, 10 and then 11, right? So these will be your 4 networks, 4 subnetworks or 4 networks, whatever you like to call. Okay, you can call it network 1, network 2, network 3, network 4, or if you want you can call it network 0. I mean, it is just your nomenclature. You can also call it subnet 0, you can also call it subnet 1, right? And you can call it subnet 2, subnet 3, like this. Okay, and subnet 4, 2, 3. Okay, now further, if you want to see that, okay, for this subnet only, what are the first addresses and what are the last address, so you can also see this, right? What is the first address and what is the last address for this subnet? The first address will be 192.168.9. all zeros, right? So let me write directly in decimal 168.9.0/26. This is the first address. What is the last address? 192.168.9. If you write all the ones, then basically from 255 you are, if you're writing all the ones, then from 255 you are skipping 192. I mean, you can do like this, or you can directly say that, okay, this is basically, if this is 64, then one lesser than this is basically 63. I mean, basically you need to convert to the decimal, that's all. Okay, so if all the ones are there, then it will be 63, right? Okay, this is the first address of this of this subnetwork. This is the last address of this subnetwork. Similarly, you can find out the first address of this subnetwork, last address of this subnetwork, and so on, right? Similarly, let me just do one more exercise. Let me find out the first network of this subnetwork and last address of this subnetwork, and then our subnetting, conceptually it is basically done. I mean, there is nothing more we need to see in the subnetting, right? So the first address will be 192.168.9.192, right? 192/26, because this is 64 plus 128, right? All the zeros will be there, and then it is 255, 192.168.9.255/26. Okay, similarly you can find out first and last address for here, first and last address for here also. Okay, that's fine. I hope you understood what I mean to say. Okay, now with this setup, okay, with this setup you might observe one thing, okay, one crucial thing. What is that crucial thing? See, by the way, I have also written on the next page all the range. Okay, if you want, you can verify, you can find out your ranges and you can verify on the next page. So I recommend you to find out the first and last of this, first and last of this, and then you just verify with the next page also. Okay, so you can do this as part of exercise. But now you notice one thing is that this address is basically, I mean, if you just forget about /26 because mask is not important, this address I'm talking about the IP address. This address is the first address or the network address of the subnet 0 or the first subnet. That is fine, but this address is also the network address of the whole thing also, isn't it? Similarly, this address is the last address of the last subnet. That is fine, but this address is also the last address of this network, or in other words, this address is the broadcast address of the last subnet, but this address is also the broadcast address of this network. Getting my point? So basically what I mean to say, that let's suppose you have divided into four networks, right? Let's suppose you have placed one router, or somehow you have divided into 4 networks, right? Let's suppose these are your 4 subnets. Okay, this is subnet 0 or subnet 1, doesn't matter. I mean, these nomenclatures absolutely doesn't matter. Okay, subnet 3, subnet 4. Right? Now, what is the broadcast address of subnet 4? It is 192.168.9.255, right? This is the broadcast address of subnet 4. Now, if someone is broadcasting in this address, but it was the broadcast address of the whole network also. I mean, let's suppose there is earlier, let's suppose whatever was the setup, okay, doesn't really matter. I just want to give you the flavor, okay. This is the earlier, let's suppose this is the outside router, okay. Now, what happens? Then let's suppose someone is sending a packet with this broadcast address. Then this router should be forwarding only to the subnet 4 or to the whole network. That is my question. Okay, let me write my question. Okay, probably you will get to understand more. So basically, suppose someone sends a packet with address of 192.168.9.255, then then that packet, then where I mean, then what this router will do, right? What outside or outer router, let me know, router will do. So one of the option is that it will forward the packet to all the host in the all the networks, or it will forward only to this, because this subnet is also having the broadcast address, this broadcast address, and before division also it was having the before division this was the address of this was the broadcast address of all the hosts. So since some host is here, let's suppose, okay, some host is sending, okay, some host is sending from here, then that host doesn't know about your internal structure. For the outside host, actually, this address is always the address of or the broadcast address of all the subnetworks or all the host basically. So that's why if the packet is coming from outside, then it will be forwarded to everyone. Okay, if the packet is coming from outside, then it will be forwarded to everyone, because the outside host doesn't know anything about the internal structure. So if packet is coming from outside, then it will be forwarded to every host in all subnets, right? That's the key. If the packet is from outside, then it will be forwarded with this address, right? Now if this network, if this someone from here is sending with this IP address, okay, suppose someone is saying that, okay, I want to send to this IP address, which is this, right? If internally someone is sending, then since internally the structure is defined, then this router will only forward to this. It will not forward to the others. Okay, I hope you are getting. So if the packet is coming from outside, it will be with this address, okay, with this broadcast address, then it will be forwarded to everyone. Basically, the thing here is that the subnetting is only known to the local things, okay, or to the local router. But for the outside world, it is not known. Okay, I hope you understood. So basically, you have divided into four networks. The first network here, okay, first IP address here in the first subnetwork is the network ID for the subnet 0 also, and for the entire network also. But entire network ID will take place into the picture only when someone is sending from outside. Similarly, its broadcast address will take place into the picture only when someone is sending from outside. But for the internal, the things are very much defined. Okay, this is the network ID for subnet 0 only. Okay, this is the broadcast address for subnet 4 only, or subnet 3, whatever you want to do the name. Getting a point? So basically for the outside world, the subnetting is not known. So for the outside world, okay, so let me write it here. For the outside world, the addresses are very much similar to same as no subnetting. Okay, which means for this host, for outside host, subnetting is not known. Understood? So the broadcast address is for the entire network, the network ID is for the entire network, and so on. Okay. For this router, yes, this router is basically For if this is the incoming, for this router, then subnetting is known. Okay. For this router, subnetting is known, or for any host inside here, subnetting is known. Okay. For everyone here in this circle, for anyone in this circle, subnetting is known. Okay. Now basically these are the combinations that we have. Okay, that's fine. So let's solve a new question. I hope the earlier division is okay to everyone. That how do we divide? Very easy. Just take 2 bits and then you just divide like this, right? Now let's solve few questions. If you borrow 4 bits from a 24/24 network, how many subnets you create? See, if you are borrowing 4 bits, then 2 power 4, right? 2 power 4, which means I think answer would be there in the next page. Okay, 2 power 4, which is 16, right? If you are borrowing 4 bits, which means /24 means, let's suppose that, see, these are the generally 4 octets like this, 1, 2, 3, and 4. And then /24. It means that these 3 are anyway fixed. Now from here I'm borrowing 4 bits, right? I'm borrowing 4 bits. So which means from here these bits could be 0, 0, 0, 0, 0, 0, 0, 1, like that, right? And 1, 1, 1, 1. So 2 power 4, 16 networks we can create. 16 subnetworks we can create. If subnet mask is this, okay, what does this mean? It means that basically it means that you are having 1, 1, 1, 1, 1, 1 or everywhere, which means 16 ones are there. And then how many ones are this? I think these are basically 15 lesser than that, right? So you don't have this, which means all of these are 0, which means that 15, which means that 4 you don't have, right? Which means that you have 4 initial 4 are ones here, right? I mean, if you represent 214 binary, it will be something like this. Okay, because 15 lesser than 255, which means you don't have this, right? You don't have, I mean, you have zeros here. So which means 24 plus 4, 28, right? This is /28. This is basically saying /28. So how many usable hosts are possible, they are saying. So /28 means you have 4 bits left, which means number of IPs which are there is 2 power 4. I mean, 2 power 4 IPs are possible because 4 bits are only left, right? Which is 16. But number of usable host, I mean, you don't generally assign first and last, right? So that's why usable hosts are 16 minus 2, which are 14. Okay. You just remove 2 for the usable host, right? Okay. Now let's see this question. An organization block address this 120. So they are saying already /24 network you have. Now that organization need 120 usable IPs, or I mean 120 doesn't matter. Basically you need 128. I mean you at least have to have 128, right? 128 IP addresses you have to have. So 128 means 7. So basically you can say that 128 IP addresses we need. Which means 7 host bit ID we need. 7 bits from host bits, right? Which means 24 are already booked. So these 3 are already booked. Now 8 are left. Out of those 8, 1, 2, 3, 4, 5, 6, 7, 8. Okay. I need 7. So which means I can assign only 1 bit to the subnet. Okay. So this network can be divided into 2 parts. Okay. This network can be divided into 2 parts, right? So by the way, some of the students might not be 100% understood this. So one thing, let me just tell you that there is no harm in IPs. For example, let's suppose if I have divided something like this, okay. If I have divided something like this, then there is no harm in IPs that we are doing. Which means, can you tell me number of IPs before? Which means, I mean 24 bits are fixed, so 2 power 8 IPs are here, right? 2 power 8 IPs are here. Okay, if you change, keep on changing, then you will be getting 2 power 8 IPs here. How many IPs you will be getting here? 2 power 6, because 6 bits are only free. Okay, 6 bits are only free. You will be getting 2 power 6 IPs only, right? So it's 2 power 6. How many IPs you will be getting here? Again 2 power 6, right? 2 power 6 IPs, or let me choose another color. So here it is 2 power 6 IPs, 2 power 6 IPs only. Similarly, here also 2 power 6 IPs. Here also 2 power 6 IPs, right? So if you add all of this, 2 power 6 plus 2 power 6 plus 2 power 6 plus 2 power 6, which is 4 into 2 power 6, which is 2 power 2 into 2 power 6, which is again total combinedly 2 power 8 IPs. I mean, earlier also 2 power 8 IPs, now also 2 power 8 IPs. So basically, obviously, we are not losing on the IPs, okay? I mean, the number of IPs will be same, it's just that we are dividing into the networks, okay? Into the subnetworks, that's all. So now coming to this question, they are saying there is one organization, okay? The organization is 14.24.74.0/24. This is the organization. Now they are saying this organization need 120 usable IP addresses, okay? So basically an organization is assigned a block address of this. The organization need a subnet that can accommodate 120 usable IP addresses, which means you cannot have 120. Basically, that you can say 128 IP addresses it needs. Okay, IP addresses it needs. Which means 128 IP addresses it needs which means 7 bits from host ID are needed. Okay, so 8 bits are available, so 7 bits are needed, which means you can use just 1 bit for the subnet. Okay, /25, which means you can just use just 1 bit for the subnet, which means you can divide this network. Okay, you can divide this network into 2 parts, because just 1 bit, which means two subnetworks, right? So what are those 2 subnetworks? Let me write it. So one of the subnetwork will be 14.24.74. This will be 0, and then you can write obviously anything here, 25. Another subnetwork will be 14.24.70. This will be 1/25, right? If you ask me the network ID, then the network ID here, the subnet ID or the network ID, whatever you like to call, it will be 14.24.74.0/25, because everything is 0. And here it will be 14.24.70.128/25. Okay, it will be 128/25. This is the network ID for the second subnet. So you can divide this network into 2 subnets, and one of the subnet you can give to the organization. You can say that, okay, you can use this subnet or this subnet, doesn't matter, because both of the subnets are having equal, like 120 and 2 power 7, right? 2 power 7 IP addresses. So 128 IP addresses. You can use any of the block. Getting my point? So /25 is needed, basically, you can say, right? /25. Now they are saying that organization needs to allocate a subnet for 60. So 60 means the nearest 2 power is basically 64, right? So what is the smallest subnet mask that can accommodate it? Okay, so you need 64, which means that host ID, from host ID you need 2 power 6 bits. Sorry, 6 bits, you can say. Okay, because 2 power 6 host you need, right? Host or IP addresses, doesn't matter. So I mean, this is a +2 also. Usable IP address means which means that extra +2 you will be anyway doing, because these are the hosts. So +2, 62 you will be needing, but nearest is 64 actually. So don't worry about this +2 -2. They won't play around these things much. But I have given you enough information, even if they play around. Otherwise, they generally don't do such dirty tricks. Okay, I mean they will not play around these things. Yeah. So you need 6 bits from the host ID, right? So basically currently you have 8 bits from the host ID. Now what you can do, see, you can divide this. Okay, you can basically you need just 6 bits, which means you can borrow 2 bits, right? So you can divide this into 4 networks or just 2 networks, which means see what I'm trying to say. This is 14.74.74.0/24 network it is, right? One option is that you can divide it into 4 parts. Okay, you can divide this into 4 parts. Everyone is /26. Obviously, everyone is /26. Okay, which means the first network will be 24.74. This is 00, and then you can write anything here like this, right? This is 01, and then you can write anything. So you know the whole story. So this is the option 1. Okay, because every of this is having 64 IPs. Okay, and we need just 60 IPs. So this can fulfill, any of this block can fulfill. So this is basically option 1. Okay, another option here could be you can have the same thing /24 and then divide this into just 2 parts. Okay, /25 and every of this will be having, since it is /25, so 2 power 7, 128 IPs. Okay, this is also having 128 IPs. And for the /25, you will be having something like this. You can say it will be 14.24.74.0, and then you can have anything here, right? /25. Similarly here 14.24.74.1, and then you can have anything here /25, right? So this is the another option, because since we need just 60, so this block, I mean any of this block or any of this block will fulfill the requirement, right? So whether you want /26, /25, it is up to you. I would prefer that we should go for the minimum wastage. I mean, if we need 60, then we should allot this. Why we are allotting 128 IPs, right? I would prefer this way. Okay, so basically 26. So I would say that 26 is the better. A smallest subnet mask that can accommodate basically the terminology here should be smallest in terms of the number of, basically the terminology could be like a smallest subnet. Okay, a smallest, let me just remove the mask thing here. A smallest subnet that can accommodate. Okay, this is the smallest subnet, 64 IPs, right? This is instead of mask, let me write a smaller subnet. Okay, because we should always prefer the smaller subnet. Okay, this is the smaller subnet. So this is option 2. Out of both the options are okay, but I would prefer the option 1, because in option 1 we are assigning this, which is enough. Why to assign 128 IPs block, right? Because they will be wasting. We can assign this to something. We can use these 3 to some other purpose, right? Okay. Now let's just see this question. What they are saying. Let's just divide this each into the. Let's just divide this such that each network has 10 hosts. 10 hosts means closest is 16, right? 16 hosts. So which means we need 4 bits. 4 bits from host ID. Right? So currently we have 8 bits available. So we just need 4 bits. So we can use 4 bits for the subnetting. Okay. So this is /24 network. So since we are using 4 bits from the subnetting for the subnetting purpose, that's why how many subnets we have? We have basically 16, right? The first subnet will be having all these 4 bits at 0, 0, 0, 0. Then this is 0, 0, 0, 1, right? And similarly 1, 1, 1, 1, right? So you can say 16 subnets we can have. Each subnet is basically having is having 16 hosts. Okay, 16 hosts each subnet. Understood? So actually it's very easy. Like, I mean, depending on the requirement, if I need 10 hosts, then I can give just one of this. Okay, I can just give one of this. That's fine. Okay, I don't need to give all of this, and I don't have to divide. See, here also there are multiple options. For example, this is 192.168.9. Okay, dot. So basic, I mean, these, you write x here, you write dot here, doesn't matter. Okay, don't follow me too much that okay I'm writing sometimes slash or sometimes x, it doesn't matter. Okay, basically slash 24 means these are fixed. Okay, now since you need 10 hosts, you can just divide this into two parts only. If you are dividing two parts, it will be slash 25, I mean just one bit you are using, right? In that case it will be having 2 power 7 hosts, right, which is 128 hosts, and you just need 10. So why to waste 128 block? So that's why I have divided into multiple. Okay, that's why I have divided into minimum such that everyone is just having 16. Okay, that's why I have divided into multiple. You can divide into two parts, you can divide this into four parts. See, the another option could be you use 2 bits. If you use 2 bits, you will be dividing into into the four parts, right? So every part will be slash 26 slash 26. If you are using 2 bits, slash 26 slash 26, right? Here every of the part will be having how many? 64 hosts. Okay, every part will be having 64 hosts. Obviously not useful, right? Not useful. So we want such that every part have the minimum host. I mean, if we need 10 hosts, then 16 hosts at most every part can have, right? So that's why I've divided into these many parts. Okay, this is a good solution. Okay, this is a good division. Okay, there could be the other options. You can divide into two parts, four parts, like this, right? See, slash 24 means, see, if you are having slash 24 network, any slash 24 network, there are multiple options. One option, two parts, slash 25 networks. Another option for any slash 24 network. Another option, four parts, slash 26 networks. Okay, see, slash 24 network means, you have 2 power 8 hosts, right? 2 power 8, I mean 8 IPs, basically you can write IPs. Okay, 2 power 8 IPs you have here individually you have 2 power 6 IPs, because 26 bits are used, so 6 bits are remaining. 2 power 6 IPs, 2 power 6 IPs. So obviously the IPs are intact. Okay, 2 power 6 IPs, 2 power 6 IPs. Individually, see, here 2 power 8 IPs, I agree. But here individually 2 power 7 IPs. Right? 2 power 7 IPs. Similarly, you can divide into 8 parts also. Obviously, like slash 24, you can divide into 8 parts. 1, 2, 3, 4, 5, 6, 7, 8, right? Each of this will be slash 27 now. Slash 27. Okay, like this. You can divide into 16 parts also. And 16 part was the good division for our purpose here. Understood? Because each of the part is having 16 hosts and we want just 10 hosts. Okay, so it is a good division. Understood? Now let's see this optional discussion. Okay, this is the optional discussion, optional question. Here we need to divide this into 7 network such that network 1 is having these many hosts. Okay, let's suppose these are hosts. Okay, so if these many hosts, then closest is 2 power 9. 2 power 9 IPs I need. Closest is basically 2 power 8 IPs I need. 2 power 8 means 256. Closest is, I think, 2 power 7 I need. Closest is 2 power 6 I need, right? Closest is 2 power 5 I need. Closest is basically 2 so basically 2 hosts if I want, then 4 IPs I want, right? So 2 power 2 is the number of IPs closest, 2 power 2 number of the closest IPs, right? So basically these many IPs I need. Basically instead of, I mean, you can forget about this number. Basically this number is not much relevant now. Basically we want these many IPs. Okay, from each of the network we want these many IPs. So we want to divide such that each network has these many IPs. So let me just write like this. This must have 2 power 9 IPs. This is 2 power 8 IPs. This is just optional discussion. I am doing it. I don't think it is needed for this video, but let me quickly do it. Okay, 2 power 6 IPs and then 2 power 5 IPs. Then this is 2 power 2 IPs, like this, right? Okay. So this slash 16 network, by the way, okay, this is slash 16 network. One way is that, this is very interesting question. See, one way is that you need 2 power 9 IPs, right? So 9 bits you need from the host ID part. So which means you have 16 bits available, 16 host bits available with you, right? 16 host bits available, right? So I need just 9 bits. So 16 minus 9 will be how much? 16 minus 9 will be 7. So basically 7 bits you can use, which means, see, this is slash 16 network, right? Slash 16 network. Let me write the whole network if you want. So this is 172.16.0.0 slash 16. So this is anyway fixed. Now you can borrow 7 bits. Okay, you can borrow 7 bits. Okay, these are the 8 bits, so you can borrow 7 bits, and then since you are borrowing 7 bits, you can divide into 2 power 7 such networks. Okay, so you can divide 2 into 2 power 7 such networks. So since you are borrowing 7 bits, so 16 plus 7 will be how much? 23, right? So slash 23. So every network will be slash 23. Understood? So every network will be slash 23, and every network will be having 2 power 9 IPs. Every network will be having 2 power 9 IPs, right? 2 power 9 IPs. Every network, isn't it? So how many? 2 power 7 such subnetworks. Then you can assign this block to this, that okay, I need for the first subnetwork I need 2 power 9 IPs, that's fine. For the second I need 2 power 8, but I have 2 power 9, that's fine, I can assign, right? For the third I need 2 power 7, but I have 2 power 9, then that's where I can also assign. So I can assign, that's fine, but it is basically overkilling. I mean, see, these are the many networks. So this is, let's suppose, the 7th network, and 7th network is also having 2 power 9 IPs, and I'm just giving to this which just need 2 power 2 IPs, something like this. So it is overused or overkilled. See, slash 16 network I have. Slash 16 means 2 power 16 total IPs I have. Okay, you understand like this, right? Now there are many ways to do it. Okay, you can divide into 2 parts, 2 power 15 of 2 parts. Okay, so let me first divide. Okay, this division is fine actually. Let me first divide into many parts, which is 2 power 9 IPs in each part. Okay, in each part I'm having 2 power 9 IPs. Okay, how many parts are there doesn't matter. You can calculate. I think this is 2 power 7 parts, which is fine. Okay, see, don't worry about the subnetting and all. It is just a pure aptitude question I'm doing. 2 power 16 such, suppose chocolates are there with me. Okay, then I'm dividing into 2 power 9 group. Okay, 2 power 9, 2 power 9, 2 power 9, some groups. Okay, I mean 2 power 7 such groups are there, but number of groups are also not much of my interest. Okay, this first group of IPs I can assign to the network 1. That's fine, right? That's fine. I can assign to the network 1. But if I assign this to the network 2, but network 2 only need 2 power 8 IPs, just half of this. So is it wise to assign directly this block to the network 2? Then obviously no. So what will I do? I will further divide this. This is interesting. I will further divide this into 2 parts basically. Okay, of 2 power 8. This is just aptitude question. Don't worry about the subnetting and all. 2 power 9, some blocks are there, some chocolates are there. I can divide into 2 power 8, 2 power 8, 2 parts, right? 2 power 8, 2 power 8. The only thing in this aptitude question is that I need to divide. Whenever I'm dividing, I can divide into the power of 2. Then only the mathematics will work, right? If I'm dividing into 3 parts, then how to divide? I mean, then it will be the fraction and all, right? So okay, so I can divide these 2 power 9 IPs into 2 parts. Then this part I can assign. Don't worry, I will come to the subnetting part also. But currently I'm doing with the aptitude perspective. This part I can assign to the network 2, because network 2 just need 2 power 8 IPs. Now network 3 need 2 power 7 IPs. So should I assign this whole to the network 3? No, I can further divide this into 2 parts. Okay, 2 power 7, 2 power 7, right? And then I can assign one of the block to network 3. So this is 2 power 7, 2 power 7. And I can assign this to network 3. Right? Now network 3 is done. Okay, I can assign. Then network 4 need 2 power 6. Should I assign this whole to network 4? No, I can basically, I can further divide it into two parts, 2 power 6 and 2 power 6, right? 2 power 6, 2 power 6. Then I can assign one of the part. It's not necessary I need to assign this only. I can assign this also. I can assign one of the part. Let's suppose this, okay, to network 4. Now, network 5 needs 2 power 5 IPs. Should I give whole? No, I can further divide. Okay, that's very interesting that I can further divide this into two parts. Two power 5, 2 power 5. Then I can give this to network 4, network 5. And then I can assign this this to network 5. And then let's just see network 6 need. Network 6 just need 2 power 2 IPs. Should I assign this whole to network 6? Obviously no. So let me divide this into multiple parts, each of this 2 power 2. If this is 32, okay, 32 IPs, if I'm assigning into 4, then I think 8 parts it will be divided. 4. Okay, each of this is 2 power 2. Each of this is 2 power 2. Okay, let me divide into 8 parts. Then let me assign this to network 6, right? Because network 6 just need 2 power 2. And then network 7 also need 2 power 2. So I can assign this to network 7. One of the block here to network 7. See, earlier I was assigning these whole, okay, these many, okay, these say 7, 8 big chunks to these networks. Now just 2 chunks are enough, and out of these 2 chunks also few are remaining, okay, few IPs are remaining, few blocks are remaining. So smartly you can assign. Getting my point? So basically, if if these kind of questions come, then first you sort based on the number of IP. Okay, first you sort. Okay, what is the biggest number? Then second big, then second. I mean, they might not be asking such question, but still, if they ask, like in the worst case, I'm just letting you prepare. Okay, because this question has been given in frozen book. So if this is given in frozen, then probably they may ask, like, I don't know, I do not know, but we should be prepared, right? So basically what I'm saying is easy only. It's easy only. Given a block, okay, first just see that, okay, 2 power 9 chunk you need. Okay, 2 power 9 chunk you need. So let's just divide into 2 power 9 chunks, right? But do not assign the second chunk directly. You can further divide this because you just need 2 power 8. You can further divide this like this, right? So how to divide? Basically, whatever is the 172.16, right? See how to divide. Let me just tell you. It was 172. Let me just zoom it a little bit. Okay, it was 172.62, right? Dot 16. 172.16.0.0/20/16, right? /16. Now, if you are dividing into let's suppose 2 power 7 parts or 2 power 9 IPs, then 7 bits you can use here. Okay, so first 7 bit you can use 0000 000, right? First 7 bit will be like this, and then this could be anything, right? And similarly here 00000001. Okay, these are the first 7 bits, right? And then this bit could be anything. Okay, and then you can further take, okay, since you are dividing this, then basically you again need to borrow from the host ID. So you can again make this, okay, 0 and or 1, which means 0000 is already 001. This is already fixed. Then if you make it 0, this you will getting this network. If you are having 0000 001, and then if you are having 1, you will be getting this network, right? And then if you can further divide, then you can take the bits from the next host ID. So basically, this is, to be honest, this is the calculation is not very important. Although I have given you the calculation, if you want, you can just check your numbers. Okay, you can write your numbers and can verify the first address and last address in the network. I have given the detailed solution in the complete course. This is the compact course, so I'm not giving you the solution because it's not very important. Just I wanted to give you the idea here that what you can do. You have a bigger chunk, then you can divide into a smaller chunk. Then you do not need to assign every smaller chunk. You can take that chunk and you can divide further. That's the only idea I want to convey with this example. Okay, I hope you understood. Although also you can completely skip this discussion, doesn't matter, because in the gate I don't think they will ever ask. But the thing here I wanted to convey that you can take one chunk and then you can divide this further. Okay, based on your need. That's all I want to convey. Don't worry much about this example because this was completely optional discussion. Okay, this was a completely optional discussion. Okay, so subnetting is over. Now we will see that how the router take decision. Okay, to forward a packet from one place to let's suppose the router is getting some packet. Then how the router take the decision that okay, where to forward this packet. Okay, so that's also a very easy topic. Let's just see this topic now.